Hello guys, in this slide we are going to talk about dispersion of white light, or we call it separation of white light into different colors. And the major colors in white light is known as ROYGBIV, where the R is standing for red, O is standing for orange, Y is standing for yellow, G is standing for green, B for blue, I for indigo, and V for violet. First period. At the end of this first period, you should be able to define light, define white light and sources of white light. You should be able to explain the word ROYGBIV. You should be able to explain dispersion of white light and how to recombine them. And you should be able to explain the types of color. Now, let's talk about light. What is light itself? Before we even talk about white light, what is light? Light is a form of electromagnetic radiation with a wavelength which can be detected by human eye. What this one is talking about is that we have different wavelengths for different lights. We have visible light and we have light that is not visible. The one that we can see is known as light. We have some that we cannot see. Maybe their wavelength is very small, and we have one with me that their wavelength is very high for human eye to detect. Talk about that one later. What is white light now? We have white light to be that electromagnetic radiation that contains all the mixture of all the wavelengths which is visible to human eye. The mixture of all the wavelengths is 7, which is the ROYGBIV, normal ROYGBIV. Any light that contains the ROYGBIV is white, is going to give us white light. It contains all the color. We have different color of light. We have red, orange, yellow, and so on and so forth. But anyone that is containing this ROYGBIV is known as white light. It's known as white light. Now, sources of white light. We have different sources of white light. We have natural sources and we have natural and artificial. The natural one is the one from the sun. Sunlight is always white, and that's the reason why we can detect different colors of maybe our clothes or materials during the daytime, because it contains all the color spectrum. Sun is containing it, which shows that sun is white light. And we have some that is artificial, maybe the one from our torchlight, the one from maybe all those LED lights from the fluorescence and so on and so forth. That one is artificial. Now, dispersion of white light. What is dispersion of white light? Dispersion of white light is just like separation of white light into their different color components. As we all know that white light contains different colors. It contains different colors, at least 7 colors, which is the ROYGBIV color. How do we know that it contains 7 colors? It was Isaac Newton that first discovered this in 1666. He uses rays of light, passes through a triangular prism, and he discovered that all these colors were separated on a screen. Then we were able to discover that white color is made up of 7 colors. When white light is incident on a glass prism, the light is refracted into different rays when incident on the screen to produce 7 different colors, which is popularly known as the ROYGBIV. And that is the separation of white light. This is the diagram of how it is done. This is a white light. This is a white light coming from here, from the source, maybe from torchlight or from sun. When it passed through this rectangular prism here, by coming out from this place, it will be refracted into 7 colors, which is red, orange, yellow, green, blue, indigo, and violet. And this is what we call dispersion of white light. This is separation of white light into different components. We have all these color, they have different wavelengths. They have different wavelengths. We have this one, red, to have the highest wavelength. If you have highest wavelength, you are going to have small frequency. This is what I mean by that statement. This is wave. This is wavelength, the distance between two successive crests and trough. If we have wavelength to be this, therefore, if this wavelength is much, therefore the number of circles you are going to have there is going to be, if this wavelength is large, the number of circles you are going to have there is going to be small, and if it is small, the number of circles you are going to have there is going to be large. And that's the statement concerning frequencies and wavelengths. You cannot compare this one with this one. The wavelength here is very small, but the frequency is much more than this one. This one is just having like 1, 2, 3, 4, while this one is having more than that. And that is that concerning we have decrease in wavelength from red to violet, which means that the wavelength decrease from red to violet, and we have increase in frequency from red to violet, which means that the violet is having the highest frequency while red is having the smallest frequency, but red is having the highest wavelength while violet is having the smallest wavelength. Increasing in refractive index, it means that the violet is having the highest refractive index, and so on and so forth. This is their probable wavelength. This is their probable wavelength, range of wavelength of this color. We have violet to have 3,800 to 4,500 Armstrong. Armstrong is 10 times 10 raised to power minus 10 meter, while red is having the highest wavelength of 6,000 to 7,000 times 10 raised to power minus 10, which is Armstrong, which means that red is having the highest wavelength, violet is having the smallest wavelength, like that. Therefore, this one is having the highest frequency, while this one is having the smallest frequency, vice versa, like that. Frequency is inversely proportional to the wavelength, and that is that concerning that one. Now that's the end of the first period. At the end of this period, you should be able to define light. By now, I told you light is electromagnetic spectrum. We have white light to be the electromagnetic spectrum that contains all the visible wavelengths, that is the ROYGBIV, which is 7. Dispersion of white light was discovered by Isaac Newton in 1666, when he passed light through a rectangular prism. He discovered that it was separated into 7 different colors, which is popularly known as ROYGBIV, and that is that concerning that one. Now this is beginning of second period. At the end of this second period, you should be able to explain colors combination. With the aid of diagram, you should be able to explain diagram. With the aid of diagram, you should be able to explain color recombination. You should be able to explain the Newton disk and secondary color. Let's begin. Recombination of spectrum. After white light has been separated into different spectrum, it can be turned to white light back through some mechanism. Look at this diagram here. If we use triangular prism to separate it like this, we can still use this same triangular prism to combine it back into white light like this. What we just need to do is we reverse the process. When the light is being separated after passing through this first triangular prism, we just reverse the process and it will turn it back to white light in that manner. And if you want to widen it more, we still raise it like this. This is what I mean by that statement. We have this. If the color is coming like this and it is being separated like this, if you want to make sure that the thing is wider, we use this one. It will make it wider again. But if you want to recombine it back, what we do is we reverse the process. When the thing is coming like this one we combine it back into one, and that's what we call color recombination. We use triangular prism to separate it, and we can also use triangular prism to recombine it. Newton colored this. Sir Isaac Newton discovered that when he painted disc into 7 different colors, the ROYGBIV, when he painted into 7 different colors, the color were very distant. You can see it clearly. But when he spined the disc, when the disc was in motion, rolling like this, he was unable to see those colors again. It were just displaying white color, which shows that white color is a combination of the different 7 color, and that is that concerning Newton disc. Forms of color. We have different forms of color. We have primary, we have secondary, and we have complementary. What is primary color? These are colors on spectrum which cannot be produced by mixing of any color together. We have red, green, and blue to be primary color. They are natural color. They are not being created by the mixture of different colors. They occur naturally. Why secondary color? These are colors formed from primary colors. They are color obtained by mixing of 2 primary colors together. When we mix 2 primary colors together, it will give us secondary color. E.g., if we mix green plus blue, it will give us cyanide. If you mix blue plus red, it will give us magenta. If we mix red plus green, it will give us yellow, and that's secondary color. We have complementary colors. These are 2 colors which gives white color when mixed together. If there is any color that when you mix it with another color, it will give white, they are known as complementary color. We call them complementary colors. Now, apparent color. Apparent color is, what we mean by this color of object is when there is ray of light and it falls on any materials, that material is going to absorb all the color in that ray of light. You know that we have 7 colors in most white light, in every white light. So when this material absorbs all those color, the color that this material cannot absorb is the color of that materials, and that's the color that the material is going to reflect. The color reflected by that material is known as the color of the material. If you are seeing red, it means that it has absorbed all the other color from the ROYGBIV except that red, so you reflected the red. If you are seeing blue, it means that it just reflected the blue. It has absorbed others, and that's what we mean by color of object. We have pure, impure, and monochromatic light. Pure spectrum in which the dispersion is highly discriminative, so that at each point the light is practically monochromatic. What we mean by monochromatic is light of one wavelength. When we have light that they do not cross each other, we call them pure spectrum. But impure spectrum is in one in which the color overlap, they cross one another. We call it impure. So, and that is that concerning this class. So at the end of this class, you should be able to answer the assignment by mentioning 3 primary colors combination and their results. Explain with the aid of diagram, color spectrum. Question number 3, explain the Newton color disk. Then what is secondary color? Then explain with the aid of diagram Newton color disk.